Hi and welcome to the Produal training video series. In this part, we are taking a little bit deeper look on the products and their functionalities, WTRs, WBUs, and different kind of functions that we can change over the My tool. Let's start with the WBU. So, first we make a Bluetooth connection to the WBU. What we will do is that we will take a little bit deeper view on the WBU settings. There is a lot of different kind of settings, from configuring inputs and outputs, network settings, and so on. All the settings of the WBU can be found behind of the configure manually. All the settings can be also saved to the cloud or phone's local memory. You can get access to those by selecting Select from local storage or Select from My cloud. But now let's start. We select Configure manually, and next what we can see here in the upper part is the WBU hardware inputs and outputs. These are those physical inputs and outputs that we can find from the WBU. So, like earlier we have gone through, the inputs can be found here on the bottom part of the WBU, and the outputs can be found here on the top part of the WBU. So, let's start with the inputs. Here on this page, we can see that we have 6 slots or 6 inputs that we can configure. The first one shows us not used, so we select here. And now what we can select is 0 to 10 volt, NTC 10, PT1000 or digital input. Next we will go to the outputs. There is 6 outputs of 0 to 10 volt, and we can read temperature, humidity and CO2 and convert those measurements as 0 to 10 volt outputs. Also, those outputs can be driven over by using BMS system. So the WBU can be used as a remote I/O unit. First, if we want to use this output with some transmitter, we select transmitter ID. Next, we have a voltage selected. Then we select wireless input. So here we will select the transmitter ID that we are using. So we will now select number 1. And then what is the measurement that we are converting as a 0 to 10 volt output? In this case, I will use temperature. After I have selected all needed settings, I need to select Edit Parameters. From here, we can see that there is a measurement source. In this case, it's an internal temperature sensor. All the basic WTR has a basic internal temperature sensor. But the example WTR-IM has an external measurement that we can select in this here. But in this case, we are using now this internal temperature sensor. Also, it is possible to select transmitter offline value. So if the transmitter is dropped from the network, we can give some specific value out from that output. In this case, it's 0%, but if we want to have there something else, we can freely select it by using this plus and minus button, or just write it manually here. But let's use 0. Now we have a scale low point and scale high point. What this is doing is that we can select what voltage is given out from the low point and what voltage is given out in high point. Now, as a factory setting, temperature is starting from 0 degrees and 0 voltage. If I want to scale it so that we are using 50 degrees here as a top point or the scale high point, in this case, now let's say if we have a 25 degrees Celsius, it will give us out 5 voltage. So we can freely scale the output here. Also, if I have an application where I want that there is always 1 volt base output, I can do it like this. So now in the 0 degrees, there is always 1 voltage coming out from this output. When I'm happy with the same settings, I select Confirm Changes. Here I can do the same settings for all 6 outputs, or I can select CO2s or humidities for other or different transmitter IDs. When I'm happy with these settings, I will select Confirm Changes. Now we can see that there is a number 5 on top of these outputs, telling us that there is a settings that is done for a certain area. And if we want to install these already to the WBU, we go here on the bottom part and install to device. Now the My tool is sending these settings to the WBU, and now all the settings is set up. So next we will take a look on the measurement calculations. First, what we have here is average groups. WBU has 5 average groups, and we can freely select measurements to each of these groups. How it will work is so that first we select the group and the measurement that we want to average. Here, as a factory setting, we will find that the temperature is inside of the group 1, and we click Edit Parameters. Here we will select what the sensor is used. Is it this internal sensor, or is it using these external sensors that are available, example in WTR-IM. From selected transmitters, we can select transmitters that are added on the average group. As a factory setting, it's all 100. By selecting Edit, we can see that here is now this type of table where we can select freely transmitters that we are using in the average calculation. I click Reset Selection, and now I can select freely all the transmitters that are added on the group. You can see also that number 1 and 2 are black and the rest of these numbers are gray. What this means is that there is installed already number 1 and 2 on the network. If I select 1, 2, 3, 4 and 5, and 3, 4, 5 is not added on the network later on, that doesn't matter because the gateway doesn't take those account in the average calculation if there is no transmitter installed. If I'm happy with these, I select Confirm Changes. Next, I can select average high cutoff and low cutoff. What this is doing is that taking away from the average calculation temperatures that are over or under these set points. So, example, if there is a transmitter that is too close of heater, or there is a transmitter that is too close of cooling devices, we are not taking those inside of the average calculation. When we are happy with these, we can select Confirm Changes. Also, good to note is that in some of these applications, there is this big question mark in the top of the corner. By selecting that, it's giving you info screen where you can see what this function is doing and what type of things you can do with this function. Here on the measurement alarms, we can see that there is a list of different kind of measurements where we can set an alarm. The alarm is working so that there is a Modbus register for each alarm where the flag will go up if some transmitter is going over or under set point of these alarms. So here I will put now the low set point for temperature as a 10 degrees and high point as a 40 degrees. Also, we have a condensation alarm here, but we will go more deeply on that part on the WTR-IM part, because this is the function that works only with WTR-IM. Next, we have a temperature stability. On this application or function, we can follow up how good the measurements are keeping inside of certain tolerance. Here we can set the low and high point. In this case, we will put 10 degrees as a low point and then 30 degrees on top point. In this function, the WBU is calculating how long time the temperature has been between of these low and high point. We can select the time window and if the temperature is kept between 10 and 30 degrees, whole 24 hours will give out as a percentage of 100. Next, on the bottom part of the configuration, we have a communication section. First, we can see here is the Modbus register grouping. Modbus register grouping is working so that you can freely select different kind of measurement types from 1 to 10 in these groups. WBU is grouping those registers so that you can use Modbus function read multiple registers. This makes easier and faster to read values from the WBU. Each group has a fixed Modbus address space, and you can then select what measurement is shown on this fixed Modbus register area. Next one, we have a value over bus. Value over bus is a function that we can use with the display model WTRs. Bob is working so that you can write any supported value to the WBU, and WBU is then transmitting this value to the display of WTR. In the Bob, we can have three values shown in the display model of WTR. First, we can select what is the bus mode: global type and value, global type, individual value, or individual type and value. In the example, we will use outdoor temperature, so we will leave the global type and value, and then we will select bus value type as outdoor temperature. What this will do is that when we have a display model of WTR, it will show this value as outdoor temperature without any scaling. The outdoor temperature is needed to write over the Modbus on certain registers in the WBU from the building automation system. Also, we can have other Bob values like water consumption, energy consumption, and so on. There is a long list of supported different kind of values that we can then shown in the display models of the WTRs. Next, we have a wireless network settings. Under the wireless network settings, first we can find offline alarm. This is the time that it will take that the WBU is triggering an alarm of lost transmitter. Factory setting is 7,200 seconds, same as 2 hours. Next is battery alarm limit. Then we have a gateway pole interval and transmitter activity interval. These two values are most important of the WBU and the wireless network. Gateway pole interval is the value how often the gateway is asking the measurement for each transmitter. Transmitter activity interval is the time how often the transmitter is waking up, making a measurement and going back to sleep. Transmitter indication LED flashing can be enabled or disabled. If this is selected as a disabled, the transmitter does not flash the LED when it's rebooting or losing network connectivity. This is a setting that is usually used in hotels and areas where we don't want that the LED will flash at the night time. Keep last value. This is the setting where we can select if the transmitter is dropping from the network. Do we want to keep the last valid value or do we want to put it as a 0? Network level WTR language setting is so that we can select are we using English or Finnish language or other languages in future. Currently, only the English language is supported. Global COV settings has 3 different values: temperature, humidity, and CO2. If we set some value, example 100 ppm for CO2, this is the limit that the measurement needs to move before the transmitter is sending the measurement to the gateway. This is not affecting to the gateway pole interval, that is still on use even if we are using COV settings with the transmitters. Last, we have a general communication settings, and from here we can find basic settings for Ethernet and RS485. Ethernet has settings for IP address, and RS485 has settings for Modbus RTU, where we can change normal IDs, speed, and so on. Also, on the last one, we have a radio settings where we can disable this beacon message from the WBU. When we are happy with all settings, we can choose Install to Device, and this is now writing all the settings to the WBU. If this is a type of setting file that we can use in the future, we can also save the same setting file to the cloud or local memory of the MyTool. In this case, I select Save Configuration and Save as My Cloud Configuration. Here I can put a name for this setting file. and comment, and I click Save. Now this setting file is saved to the cloud, where we can use this later on in other WBU installations. Next, we will take a little bit deeper view on the WTR-IM. WTR-IM is an input module for external measurements like NTC10s, digital inputs, resistance, or 0 to 10 volt. WTR-IM has 3 inputs where we can put these external measurements. We have a spring-loaded connectors for easy installation. Also, we have a possibility to have an external power supply from 10 to 30 volt DC or AC. WTR-IM is also possible to power up with the battery or use this battery as a backup power supply if the main power supply is lost. IM is also including temperature and humidity measurement in the PCB, so this is a very multi-usable device. Next, we will do installation with the WTR-IM, and we will install a couple of external measurements. So let's take a connection to the IM. Here in the configure manually, we can see that there is no user interface settings, and we have measurement settings. Here we have a setting for each of these 3 inputs, and as a factory setting, number 1 and number 2 is NTC10, and the number 3 is 0 to 10 volt. We will use it so that we will connect first external NTC10 measurement to this IM. I'm using here as external NTC10 measurement Produal Academy 4 NTC10 cable sensor element, so that we are connecting. It's now on the input 1. Then, a little bit extra, I will have a water leak sensor that I'm using here. So this is a WBU, which is a water leak sensor, and this is I'm connecting now on the input number 2. No. Okay, now we have installed those on place. We test that they are on their place. So in these settings, we can select off 0 to 10 volt resistance, NTC10 or contact. Now I'm using NTC10 for this NTC10 measurement, and also NTC10 for this external WBU, which is a water leak sensor. And I will select this number 3 as a contact input. Usually if you are using contact input, normal open is something to use, otherwise it will overload unnecessary the battery of the WTR-IM. From the transmit settings, we have 2 settings, first transmitter interval and also external power. Now this is set as a factory setting for battery operated, but if we are using external power supply, we can select it from here. Note that if you are using battery, don't use the external power supply setting, otherwise the WTR-IM will consume battery very fast. When we are happy with the settings, we check confirm changes. Install to device. When we are happy, we will end commissioning of the device itself. Now, when we are using example this type of water leak sensor, we can have a small demo here. So how I will show this is I will go to the wireless installation project, and then I take here scan beacon data. From here we can see it's this transmitter 1, and we click show device data. Now WTR-IM has these 3 inputs where we have this external temperature, this TEQ4 temperature. I take it on my hand, I start a little bit warming it up, and in some point it starts to go up. We do it so that the WBU is also a temperature measurement. And the reason for this is that we are using temperature measurement to recognize when there is a water leakage or no. So in this case, I will use water. We can see that it's minus 45 degrees, and I split it a little bit water here. Not too much, but enough, like this. I hope it is enough. And we put our sensor there. So next, we wait, and in a couple of minutes, it should go so that this minus 45 degrees goes somewhere on 10 to 20 degrees, and that's the recognition of that there is a water leakage. Now we can see that there is a water leakage in the system, and the temperature has gone from minus 45 to 59. So this is way how we are using this NTC10 input also with the VVA2. Also what we can see is the temperature on my hand, this TQ4, is rising up on 32 degrees. Also we have this input number 3, where we have a binary or digital input. Now I make a shortcut or short loop here on the number 3, and we can see that now the binary is going from number 1 to 0. And so we can see that the digital input has gone from 1 to 0, and I'm breaking up now the circuit, and it's going back to number 1. Like this. So next we will take a look on WTR-AK. WTR-AK is an advanced knob UI transmitter that can be used for multiple needs, for controlling air handling units, fans, temperature, extra time, blinds, lights, and so on. It also has a very nice backlight display that can be used for showing different kind of measurements, temperature, humidity, CO2, and so on. But let's take a look what we can do with the WTR-AK. So now we have a connection to the AK. So we will select configure manually. From here we can see in the top part of the menu we have a UI setting where we can see display and knob settings. From here we have a lot of different kind of settings that we can use to operate and adjust display on the way we want it. So first we have here is a display brightness. This can be from value 1 to 10 or value 0, that means off. The same display settings is working also in basic WTR-D models. Next we have a display mode. This is so that we can select how we are showing values on the display of this WTR-AK or WTR-D. So here we have an upper value scrolling and lower value static, or vice versa. This means that if we select now the upper value scrolling, the smaller value on the upper side of the display is scrolling, different kind of values, and the main value, the big value in the middle of the display, keeps on static and is showing the same value all the time. So we are using it like that. Next we have this display static value is the value that we are showing on the display all the time. Now in this case we have a CO2 and we are using that. Here on the scrolling values we can select the different kind of values that we want to scroll on the display. Here I have selected temperature and humidity, but also example CO2 or VOB values can be selected. In the static value it's also possible to select those VOB values if wanted so. Then we have auto scroll time. This is the time how often the value is changed on the display. Display always on is the mode that we can use to force display always on. Normally the display will turn itself off after 10 seconds. Next we have active knob settings. Here we have a list of different kind of settings that we can select it for the active knob. We have temperature set point, temperature deviation set point, fan speed, extra time, percentage set point, and CO2 set point. In this case I will select all of these for demo purposes. Also we can select which is the default function of the active knob, but in this case I don't use any default value. Next, we have a settings for active knob temperature settings. Here we can set range of minimum and maximum value, what is the size of steps, what is the temperature deviation set point range, temperature deviation set points range min and max, and also what is the step size. Also, we can select that is there a 1 decimal or 0 decimal used in the deviation set point. On the active knob fan speed setting, we can select that what type of values we are showing. In this example, I'm using speed 1, 2, day, night and auto. These can be freely selected what type of values we want to show on the menu screen. Active knob extra time setting is something that we can use for adding extra time, example for air handling units or lights. You can select is it hours or minutes. In this example, I'm using minutes, and then we can select it which is the maximum time of the minutes that we want to have in this knob. Then we have active knob percentage settings. Here we can freely select that which is the size of the steps of the knob, what is the minimum and maximum value, and also what kind of symbol we are showing in the display screen. So here we have a lights, temperature, cooling, fan, heating, blinds and humidity. In this example, I'm now using blinds. In the last one, we have active knob CO2 setting where we can set which is the set point for the CO2, set point step size and minimum and maximum value. When we are happy with these settings, we can set confirm changes and install to device. Now we have done all the settings to WTR-AK, and next we want to little bit have a look what we have done here. So there is a push button on the side, and by pushing once it is activating a display, and pushing a second time we get access to these different kind of menus inside of the AK. So here with the push button we can scroll through all the settings what are here. Now when we are example here on the temperature set point, by turning the knob we can move and change the set point of temperature. By pushing the button we can get this temperature deflection, and same thing here we can do the deflection set point here. Next we have a fan speed, and we have here auto, 1, 2, day, night and so on. From here in the extra time we can add extra time with 1 minute steps up to 90 minutes. Here we have a blind control, and by turning we have a 10% steps for the blinds. CO2 set point, here we can set the set point that we want for the CO2. Also, by turning the knob on the main page we can scroll the upper value where we can see humidity and temperature, and on the main screen we have CO2. WTR-PK is a passive knob that can be used for adjusting temperatures and other set points, but is a fully passive setting, so there is no possibility to zero it over the building automation. Here we can see that the minus value is now seen here in the transmitter specific measurement, and when turning it on the other side it goes on the 10,000. Each step in the WTR-PK is 100 unit steps. The minus side is 0, the maximum plus side is 10,000, and in the middle it's 5,000. WTR-PK comes with the temperature icon and minus and plus markings, but it's also possible to order with customer specific printings like numbers and so on. Next we have WTR-PIR. WTR-PIR is a passive infrared movement sensor. WTR-PIR can be used to recognize movement in different kind of spaces like office, school, corridors and so on. Next we will make a connection to the WTR-PIR. Here we have a settings and measurement settings, and for PIR we have a couple of specific settings. First, the time unit. This can be minutes or seconds. This will affect the deactivation and activation time. So normally when we are using minutes, we have here deactivation delay of 5 minutes, 15 minutes, 30 minutes, and so on. Now if we select seconds, this deactivation delay is going to the seconds. So this is so-called slow mode and fast mode, depending on how often you want to send this movement information to the system. Then we have activation delay. Usually we are using pure activation delay as an instant, and when there is a movement, that information is sent instant to the automation. If we are using 3 or 6 second delay, that is usually mean that there need to be a little bit more movement before the information is sent to the system. Now we can go on here on the wireless installation scan and have a look how the PIR movement is working. So here we can see that there is a movement detected. So it's showing number 1. So I will put it like this, a little bit out from table, and it will zero itself after 5 seconds. And now we can see that the PIR movement detection has going 0. So I will take this WTR-PIR on my hand, and we can see that it almost immediately goes to the number 1, meaning that there is a detection recognized. And this was the deep view to the Produal wireless products, WBU and WTR transmitters. I hope you enjoyed, and we will see on the next episodes.